Hello. So in this video I just want to address a problem here. Cosine squared s equals 1/4. And at this point what they're asking you for is for what angle would this be true? So they're really kind of stretching your knowledge of the unit circle. Okay? So let's take a look at this problem. So if I start here, cosine squared s equal to 1/4. So there's a couple things here. First, s here is an angle. Why? Because the input to a trig function is always an angle, and the output is a ratio of two sides of a right triangle. Now, which two sides depends on which trig ratio you're looking at, if it's sine or cosine or tangent, right? All right, and that goes back to your SOHCAHTOA. Is it opposite over adjacent? Is it, hypotenuse over adjacent? That sort of thing. All right, so really you might want to write this down as cosine squared of theta equal to 1/4. So I think that's a little bit more clear. And then also let me mention here that the square here applies to what's directly underneath it, which is the function, right? So it's not cosine of theta squared. So in that case, the square applies to the angle, and that's a very different thing than applying to the function. So if I were to put in, say, for example, just 30 degrees, in this case, what I would be saying is this right here. I would put in the 30 degrees, evaluate the cosine of 30 degrees, and then once I got that ratio, I would square it and see if it's true that that's 1/4. Here, I would be putting in 30 degrees, squaring it to get 900, and then taking the cosine of 900. So it's not that. So really what we're solving is this right here. Now, since we need to solve for theta, what we're asking for is to really undo this cosine and then this square. So we have to take the square root of both sides, right? And so now the square root of something squared is the absolute value of that thing. And let me just take an aside here and explain why that is, just to remind you. Actually, I could probably do it on this paper right here. If I were to say I have x and this thing is squared, x is squared to be 4, for example, you really don't know if x was -2, because watch, when I put in -2 and square it, I will get 4. That's correct. Or was it +2? Because when +2 is squared, I also get 4. So you don't know if it was positive or negative. That's why you have to take the absolute value. So I don't know if this was positive or negative. Now, I go ahead and take this. This is the square root of 1 over the square root of 4. Right? So this is still the absolute value of cosine equal to, when I take the square root of 1, I get 1. I can take the square root of 4, I get 2. And now, to undo the absolute value, right, I say plus or minus 1/2. So now what I'm asking for is for what angle, right? For what angle theta is the cosine equal to plus or minus 1/2, right? All right, make sure that's in your view. Okay, so now that's the question we're really asking. And you go back to your unit circle, and remember, cosine is really x over r. It's that ratio. But when r is 1, that's really, on the unit circle, you're really saying x over 1 or just x. So I'm really looking for what angle is the x coordinate, either plus or minus 1/2, right? So that's really what I'm asking for at this point. So that's the translation of that. So then what you want to do is look at your unit circle and say, okay, where is it that the x coordinate is positive or 1/2 or negative 1/2? So if this was in radians, I believe this might have been in radians. Let's see here. Is this right? Oh, I've got this kind of cockeyed. Sorry about that. All right, so here it's at pi, no, I'm sorry, it's at pi over 3. Here x is 1/2. Also at 2 pi over 3, x is negative 1/2. Here at 4 pi over 3 and 5 pi over 3. So at 4 pi over 3, you're at negative 1/2, and at 5 pi over 3, you're at positive 1/2. So your answers are theta equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so again, this is a bit of a stretch. You're being asked to stretch and really understand the knowledge in your unit circle. All right, thanks so much for listening.